Hello. Alright guys, just a forewarning, I've got the hiccups. Hopefully that doesn't bother you guys too much. So let's take a look. This should, there it is. This should look familiar. This is, I'm going to go over how to solve E, and this is what was on the board earlier today. So if you guys didn't write it down, here's how I went over A, B, C. Now guys, remember with C, when you take the speed, you have to do plus or minus for the velocity because you're taking the absolute value. Okay, so let's take a look, guys. I would do E now by myself, mano a mano, and this is going to be changed values. So I'll get different answers than what you are going to get at home. All right, so a rock is thrown straight upward with an initial velocity of 29.43 meters per second. So your VYI is going to equal 29.43 meters per second. Alright, so your acceleration that pulls this rock back down, the rock doesn't go on forever. It's pulled back down by gravity, which has a acceleration of negative 9.81. Oops, get off there. Meters per second squared. Stating my Java. So there's the two things we really get from the initial part of the problem. The next part, when we're looking specifically at E, and we'll talk maybe later about F in a second if I get done with this fast enough, your dy, this object is going to have a dy of some value, 200 meters possibly. Now, the first thing you have to realize is that we're talking about 200 meters. Is it going to go up 200 meters? Actually, no, it does not. So the main thing we're going to realize is when is this displacement negative 200 meters? Yeah, sadly it doesn't go up 200 meters. Sometimes if it went up 200 meters, it would make a very, very interesting problem. But usually it will be further or more clear in the problem than what this is. Because this doesn't give you direction, so it has to be distance. But I guess it does say fall, so that should be negative. Okay, I see. Fall, negative. Alright, we're fine. So it says the time. Time equals question mark. Now we see these four variables again, and hopefully you guys are pretty familiar with the couple formulas you have. You don't have that many, guys. dy equals vyit plus 1/2 ay t squared. Okay, I promise to try to stop hiccuping. Negative 200 meters equals 29.43 meters per second, and I'm going to put the parenthesis around this, and this is your time, and that is plus, and I'm just going to do the 1/2 already, because when you multiply 9.81 by 1/2, you'll get a negative 4.905 meters per second squared. T squared. Alright, so there we go. We've got that first part done, and you guys should immediately see terror come to your eyes, because this is an annoying problem. We're going to set both sides. We're going to set this one side equal to 0, and it'll become fully apparent that this side is t. Now you should probably put your t squared first, but I'm being lazy. Plus negative 4.905 meters per second squared. T squared plus 200. Okay, so there we are. We've got everything done. Now, what this is going to give us, guys, is that this is in fact B, and I'll get you what these B's and A's mean. This is A, and this is C. And then I'm talking about your quadratic equation. So remember I put this on the board earlier. I'll move this off the side so I can see it. I'm going to use it as a hint because I don't actually really remember the quadratic equation very well. You can pretty much, once you become an adult, always just look it up. Negative B plus or minus the square root of B squared minus 4AC. Put that there, and all this is over 2A. So all you simply have to do, guys, is plug these in. This is going to become, oh man, I'm going to run out of space. Let's just bring it down a little further. This is going to become 29.43 meters per second the whole quantity squared, and it's negative on the outside, plus or minus the square root of b squared. This first one's not squared, I'm sorry. I'm just going to get my eraser out. There's where my b squared comes in, sorry. 29.43 meters per second, and this time it's squared, sorry. Minus 4 times AC, so that's negative 4.05, or sorry, why did I put a 0 there? .905 meters per second squared multiplied by C, which is going to be let's up to that 200 meters, and then all of this is going to be over 2 times A, which is actually going to end up being negative 9.81 meters per second squared. I'm just multiplying this by 2. Remember, we took it by half earlier. So guys, you're going to get two values. Once again, when you're going to do this, you're going to put it in your calculator. You're going to fight these numbers with your fingers, guys, on the calculator, and you should get two values. One will be possible, one will be impossible. Okay, two values, one possible and one impossible. Okay? Alright. Very cool. So let's go back now, and let's try to do F really fast. So F, find the speed of the ball at 0 meters. Okay, remember your VYI equals 29.43 meters per second. Remember, this ball is pulled back down by gravity, negative 9.81 meters per second squared. And this one says their speed at displacement equals 0. Now this one, I talk about it kind of briefly in the previous video as well. You're going to go with a very familiar formula, because it says find the speed. So it's asking you for find the speed. You're going to find your VYF. So this is one, and this is actually a formula we very kind of seldom use. You guys may be shocked, you haven't seen it in a while. It's going to be VYF squared equals VYI squared plus 2AY dy. Okay, so the nice thing about this equation in this particular moment is that your displacement is 0. So this whole term, guys, over here is in fact going to become 0. So you're basically just left with this. You're left with VYI equals VYF. So, and you're going to square it. So I am just going to I guess I'm going to bring up Excel because I don't have a calculator with me right now. So I'm going to say that this square equals 29.43. I'm going to raise it to the power of 2, and that's what your answer is. Well, to some extent, 866.124. Once again, if you want to see that, guys, when you click on it, you'll see the formula I put in. So when I come over here, I'm going to bring this off to the side of the screen. You guys won't be able to see it anymore. I can still see it. You'll see that when I square my VYI, I get 86.6 or 866.1249 meters squared per second squared. And that's going to equal my VYF squared. Well, I've got to take the square root, and I think you guys should realize what the answer is going to be around. But the interesting thing is, guys, when I bring this value back, this value, and I take the square root of it, what happens when we take the square root of any value? Well, you don't get just one answer, you get two answers. It's going to be plus or minus 29.43 meters per second. Once again, guys, if you square it, I just squared it when I did this step right here, and then I take the square root of it when I get down here. But the interesting thing is, in this process, we've lost what direction it's going. And the interesting thing is, like, it's going to happen twice. Guys, when it leaves this spot right here, do you see what I'm drawing over here, guys? It's going to have a velocity of positive 29.43 meters per second. But when it gets back to this point, when it's coming down now, the interesting thing was when it comes down, it has an equal but opposite velocity. And that's a really, really profound revelation. That when it goes up with the velocity. And when it comes down, at that exact same point, it's going to have an equal but opposite velocity. And that is actually really, really cool and a really, really handy trick to be aware of. Okay, but that's not what the question asked. The question asked for speed. And what does speed mean? It means absolute value. It kind of saps the fun out of this discovery, but what you'll realize then when you take the absolute value of this, you add a plus, you add a minus, all you're left with is the plus. So when you do that, you're left with, no matter what, 29.43 meters per second. And the hiccups are gone, and this video is over.